Hello! For those of you who have been following along on my blog before now, hooray, you get to see my face today. I'm Culver Red, and for those of you who are new, welcome to my blog. I've spent the past 6 months or so implementing the game engine that's been described by this tome of a book called the zfx-engine, and I've been live blogging the whole thing as I go. After 3 weeks of hiatus, I've been back to work, and I'm trying this experiment with video to see if I can give you a better, more informative live blog than what I've been doing in the past with text and images. I've been looking for ways to do better in my live blogging, and I figure that, hey, since I work at a software company that specializes in screen capture and video editing, why not try that? Before I get into my latest progress update, though, I want to give you answers to a couple common questions and misconceptions. Firstly, I want to emphasize that the code I'm writing is not at all original. The book I'm using, 3D Game Engine Programming by Stefan Zerbst and Oliver Duvel, is chock full of code samples. Instead, what I'm doing is approaching this as a project to help me, and hopefully you, learn about how game engines work, as well as one possible, though outdated, method of designing and organizing one. Since this book was written in 2004, I've also been trying to keep an eye on what parts of the engine would need upgrading or adding to for this to be considered a modern engine. Since I'm working in my spare time, I don't really have much in the way of an update schedule. I just get work done when I can, and I'll be posting an update every time I get to some kind of milestone and have something to talk about. So without further ado, I'll get into today's update. So the main share of my work this week was spent on implementing the book's definitions of a Vertex Cache manager and a Vertex Cache object. And what these things are going to do are manage all of the vertices and indices that make up 3D models. We're going to manage the skins that contain our materials and textures so that when we want to send information to Direct3D 9 to be rendered, it's going to do so in a performant way. According to the book's explanation, which I admit may or may not be outdated, the Direct3D renderer is actually quite bad at rendering small amounts of data efficiently, so it's much better for us to cache things up like this and send large amounts of data in a batch so that we can get better performance. So what our cache object is going to do is going to be very simple. It's going to have this add function that will add information to the cache. It's going to be holding on to a skin that contains, again, a texture and a material that will be kind of part of how we define the cache. And also it's going to have a flush method that will actually send the data out to the renderer. And just looking at the add method, for example, we're going to first check and see if this buffer, which is what it really is, it's a dynamic buffer, is large enough to hold the amount of data we're trying to put into it. If so, then we're going to see if we have enough space left in the buffer from other stuff to still hold that data, and if not, we're going to flush it out first. We're going to figure out what kind of lock we need to put on the buffer, whether or not we want to overwrite the previous data that might be in it. We're going to lock the buffer, copy over the vertices. We're going to figure out where our indices are and copy those over, and then unlock the buffers for both vertex and index, and we're done. In our flush, we're going to set our FVF. We're going to make sure our cache is active by setting the stream source of our render device, set the indices of our render device to our index buffer. If we don't have our skin active that has our texture material, we're going to activate that. I'm going to set the material, set the texture. This engine also supports wireframe mode, but it's not entirely there yet, but we do have some information here for that. We're going to activate our alpha blending by setting all these render states, and we're going to mark the skin as active, and then it's actually very simple to do the rendering. All we have to do is just call the Direct3D device draw primitive or draw index primitive methods with the information that's in our buffer. And then after that, we're going to reset our counters and just return. So how our Vertex Cache Manager is organized is through this set of functions. It's going to allow us to create static buffers that we will put data into and then never change. This will let us optimize because these static buffers will be placed inside the memory right at the base of the graphics card in the 80p, I believe it's 80 PCM slot, rather than in RAM, so it's going to take much less time to actually send this data through to the graphics card. It allows us to render out from one of our Vertex Cache objects, which are our dynamic caches. It's going to have a render function for rendering one of these static buffers we created. It also has functions to render points and lines. This is going to come in handy for when we want to have these sorts of points and lines in our level editor. And it also has methods to force a flush of a specific buffer or all buffers in case we change some setting that would invalidate the state of what's in the buffers. And that's more or less how it's organized. It also supports several different varieties of vertex cache in the dynamic caches. There's stuff for position only, untransformed and unlit, untransformed but lit, character animation vertices, 3 texture vertices, and untransformed and unlit with a tangent. So we've got some versatility there. And the other thing I want to show you is how the render function in the cache manager actually works, because this is what determines how all of our vertex cache objects are organized. So the first thing we're going to do is we've sent it a vertex ID, which is our custom type, and that's going to tell us what variety of vertex we're dealing with here. And so that'll tell us which cache object we want to put our data in. And I will then look for the most appropriate buffer to put it in. I misspoke slightly earlier. These are not cache objects themselves. They're actually arrays of caches. They can hold up to 10 each. So the first thing is we're going to loop through that particular type of vertexes array and find a cache that's using this skin that we want to use. If so, then it's got data of the kind that we want to batch together, because it's probably going to be similar in memory. And so we're going to add it to that same buffer. If not, we're going, if we can't find something with a skin, we're going to do 2 things. We're going to identify empty caches, whatever is the last found, and we're going to identify the fullest cache. Because if we can't find something that we want to add on to more data, we're going to want to see if there's an empty cache that we can use. If there's stuff that's left over, stuff that's not full yet, we'll want to put the data in there and use the appropriate skin. But if we filled up all our caches to some extent, then what we're going to do is we're going to flush out the fullest one and then take the now empty cache and put our data in that. And that is more or less how we organize our render data. And apart from that, the main things that I took care of this week were, upon trying to run this code, I realized that I had some project configurations set up wrong. So I moved a lot of the Direct3D specific code to its own project. And I also learned a very valuable lesson about using pragma once, because a lot of my includes overlap, and I was having trouble with this and had a very weird include system until I did some Googling, and because I just had enough of it and said that I'm going to actually do this right instead of what I know is a very hacky way of doing things. So that's what I have for you right now. Thank you, as always, for listening and sharing, and if you like what I'm doing, please like and subscribe, and if you have questions, comments, or other feedback, there is a link in the description of this video. Thank you, and DFTBA.